This lesson is on surface area of prisms. To find the surface area of a prism, we have to identify the different pieces of that prism. We also have to figure out what surface area actually is. And if you think about it, it's exactly what it sounds like. It's the area of all the surfaces of a three-dimensional shape. So you learned how to identify the different shapes. So now we're going to take those shapes and we're going to find what would the area be of all the outside of the shape put together. So to do that, we can do it two ways. We can draw a net and find the area of each piece and then add it all together. Or we can use a formula, and that's the way I'm going to show you today. So this is our formula here. It says surface area equals 2 times your base area. So that's what your capital B stands for. It's the area of whatever your base shape is, plus the perimeter of your base, and then times the height of your prism. So when we do this, it's extremely important to identify what your base shapes are. So when you have a rectangular prism, numbers 1, 2, and 3 are all rectangular prisms. 4 and 5 are considered triangular prisms, and then 6 is your trapezoidal prism. The way you name a prism is it names the shape of its base. So in this first one, we see it's a rectangular prism. So the base shapes are these rectangles right here. The top and the bottom. Every prism has 2 bases. So we want to find out what the surface area is of those. So we have to take 2 times that area of the base because every prism has those 2 bases. So surface area equals 2 times whatever the base shape is. In this instance, it's these 2 rectangles. For a rectangular prism, it actually doesn't matter which ones you call the bases. You can call the top and bottom, you can call the front and back, or the 2 sides. Any one of those can be considered the base because they're all rectangles. All 6 sides are rectangles. So if I'm just taking the top and bottom for these, I'm going to do 18 times 12 because that is my area of my base because it's an 18 by 12. All right, so it's 2 times the area of the base plus perimeter of the base. So we learned that perimeter of the base is that distance around the base. So in this one, it's going to be 18 plus 18 plus 12 plus 12. So perimeter of the base, and then that is going to be multiplied. This last piece is height of prism. Height of prism is also defined as the distance between the 2 bases. So I always look at it as like what line connects my 2 bases, what line touches both of those bases. So that's going to be this guy right here. So that's the height of your prism in this problem. It's going to be the number 12. So for this, you would then go ahead and solve that following PEMDAS. You'd multiply your 2 times 18 times 12, and then you'd add up all of these guys, and then multiply that by 12, and then add it all together. So we know how to do that. We know how to follow the order of operations. So today we're going to be setting up these formulas. We're going to be setting up these problems. So if you look at number 3, I'm going to just skip number 2 since it's a cube, and you look at number 3, let's get rid of some of this so we have some space. You'll notice that I'm going to say, all right, well, 3, this side here and this side here, I'm going to call my bases because this is a rectangular prism, and it doesn't have to be top and bottom. It could be side and side. So the formula is exactly the same. It does not change. So I do surface area equals 2 times area of my base. Well, it's a rectangle, so it's length times width. So it's 3 times 4 plus perimeter of my base. Well, perimeter of that base is that distance around that base, but you got to keep it consistent. Whatever you called your base, you got to stick with that one. I can't be flip-flopping between the sides and then the bottom for the perimeter. So I'm going to keep it consistent. I'm going to say 3 plus 4 plus 3 plus 4. Goodness gracious, missing my signs. There we go. And then times the height of the prism. The height of your prism is that distance between those 2 bases. So this time it's not a vertical distance because I called the sides my bases. So this is going to be the height of my prism. It's whatever connects my 2 bases. So in this problem, it's going to be the number 8. So again, you'd be solving it like PEMDAS. So let's take a look now at this next problem. This is one of the trickiest problems for kids, and it's all because of kids trying to figure out what the base is. So here, this is called a triangular prism. So triangular and then prism. So your base shape is a triangle because we name a prism by the shape of its base. So we just said it's triangular prism. Therefore, these triangles are the bases. A lot of kids like to call the bottom the base in this. But in this instance, it is those triangles. Just like in number 5, it's going to be these two triangles are your base shapes. In number 6, it's going to be these trapezoids that are going to be your base shape. And that's important because everything stems off the base. Because when you find surface area, it's 2 times the area of the base shape plus the perimeter of the base shape. So it all has to do with the base shape. So let's set this problem up. So surface area is going to equal 2 times that area of the base. We're not changing the formula at all. We're just going to see the base shapes are what are changing. So 2 times, since it's a triangle, it's 1/2 times base times height. So it's 1/2 times 6 times 8 plus perimeter of the base. Again, I'm not doing anything really different. It's just the shape that changed. So perimeter of the base is this distance right here around. So when you look at that, it's going to be 6 plus 8. And then that 1 is missing, so you look to the back triangle, and that's a 10. And then your height of your prism, and that's right here. That's that distance between the two bases. It's the number 15. So again, you could solve that. Okay? So surface area of a prism, 2 times the area of the base, plus your perimeter times height. We can apply this also to a cylinder. It's very similar. The only difference is, like a cylinder, you don't call it a prism because its base shapes, they're circles, therefore they're faces. It's not a parallelogram. So for this, we're going to use that same formula. We're going to use 2 times the area of the base plus, we're not going to say perimeter, we're actually just going to say circumference. That's literally the only difference between the surface area of a cylinder and the surface area of a prism, is that we use the word circumference as opposed to perimeter. We are not solving it any differently. We have those two bases. We're going to identify those two bases as being that circle and this circle. We're going to say surface area equals 2 times area of the base. So the base shape is a circle. Find the area of a circle. You do pi r squared. So area equals pi r squared. So 2 times pi, which is 3.14, times my radius. All right, so this problem here, I'm given that diameter, which is all the way across. So the radius is going to be half of that. So my radius for this one, since my diameter is 5, my radius is 2.5. So pi r squared, so 2 times pi r squared, so 2 times the base area, plus your circumference. We can do 2 pi r, or circumference also equals pi d. And since I was given the diameter, I might as well use it. So 3.14 is pi times my diameter, which is 5. So circumference times the height. Again, that height is the same in as a prism as it is in a cylinder. It's that distance between those two bases. It's whatever line connects the two bases. So in this instance, my height is 19. Okay, and then you would solve it using the order of operations. So again, I would do that 2.5 squared first because the E comes before everything else in PEMDAS. So cylinders and prisms are very similar. To find that surface area, which means like the area of all the surfaces, the area of the whole outside, you do 2 times the area of the base. That's where the trick comes in, is you have to figure out what shape is my base. So how do I find the area of that? So I do 2 times that, the area of my base, plus the perimeter of my base, times the height of my prism.